Okay, today's lesson we're going to solve some equations. Mainly we're going to focus on quadratics. And there's several ways to solve these. This is a review, so you should have seen all this before. I am going to focus on taking square roots. That's the easy way. Factoring is probably the one that you're most familiar with. And then we have completing the square. Hopefully you've done that before. And then when all else fails, quadratic formula. Okay? So let's talk a little bit about these quadratic equations first, because you can have different types of solutions. You can have real solutions and you can have imaginary or complex solutions. Okay? In any of these four cases, you can get a complex answer with an I in it or a real answer without an I in it. All right? So we got to be prepared for that. So what I would do, my approach to solving quadratics is first try this if you can, because this is the easiest way. For example, here's a real easy one. If I said 4x squared equals 20, then I realize there's no x term, so I can solve this by taking square roots. That is, if I isolate what's squared, and then take the square root of both sides. Don't forget your plus or minus, and I get two real solutions, plus or minus the square root of 5. Okay, now let's talk about that imaginary unit real quick. Let's just say x squared equals negative 50. Okay, so I could do the same thing, square root, square root. Now you might realize right away you're taking the square root of a negative. That's an imaginary number. I'll still do the plus or minus out front. I get x equals plus or minus the square root of negative 50, which is the square root of negative 1 times the square root of 50. So that gives me I times the square root of 50, right? Where we define the square root of negative 1 as the imaginary unit I, okay? So one more thing we have to think about here is reducing or simplifying rather that square root. So see if you remember how to do that. The square root of 50, if there's a factor under the radical that I can take the square root of, in this case 25, then I'll expect you to do that for each one, and the computer program will as well. So the square root of 25 is 5. So the square root of 50 is equivalent to 5 root 2. And my final answer, how would I write that? I would write it as 5I root 2. Okay, typically we put the I there in front of the root if we can, because if I wrote it as 5 root 2I, that just looks a little funny because is the I under the radical? It's not, but it kind of looks like it is. Okay. Taking square roots. That's what I want to do if I can, because that's typically the easiest way. And mostly I want to spend time today on these guys. All right, so let's see. So your job will be to solve and just use whatever method works. So if I look at that, I cannot solve by taking square roots. So what I need to do is factor completing the square or quadratic formula. So you may remember your methods for factoring. So let's break those down. If I want to factor, I first want to look for the greatest common factor. This one does not have one. There's nothing common to those three terms. Next thing I like to look for is kind of the easy case, difference of squares. Give you an example of that. Remember, we are solving by factoring. So not only do we have to factor, we have to do an extra step and solve. So this is a perfect square, this is a perfect square, so I can factor like this. And then remember, this last step in factoring is we take each factor, set to 0, and then we can solve. subtract 2, subtract 2, add 2, add 2. And you could have seen that probably right away. We didn't necessarily need to do all that work. In fact, you could have solved this by taking square roots. Add the 4, take the square root of both sides. Okay. My third case is what I'm looking at here. Which I like to just kind of, I'll use x squared plus bx plus c. It's called a quadratic trinomial where the leading coefficient is 1. That's typically the easy guy. And then next I'll get into the one that's a little more complicated to factor when that leading coefficient is not 1. Did I say 2? I meant 1. Okay. So in this case, you might remember you're looking for two numbers that multiply together to give you C in this formula and add together to give you B. And that's what I'm going to try and do here right away. All right, and if I want to do that, make that bigger. What did I do there? Oh, there, that's what I hit. Okay, good. All right, if I want to do that, two numbers multiply together to give me 16 and add together to give me 6. I'm thinking probably 8 and 2, because 8 times 2 is 16. And if I make the 8 negative and the 2 positive, then that should work. Remember, you can always check. We're kind of doing the opposite of foiling. If you were to check, c squared minus 8c plus 2c minus 16. And that, of course, would be where I started. Okay, so I know I'm right. Now, you can see what the solutions are. You take both of these, set to 0. C plus 2 equals 0. C minus 8 equals 0. C equals negative 2. C equals 8. And again, we can check those if you want. So there's another check. You can check your solutions. If you put in negative 2 to your original equation, do you get 0? You should, if we did everything right. 4 plus 12 minus 16 does in fact equal 0. So I know those are correct. Okay, so we talked a little bit about this method. And this method, I did a quick example, difference of squares. That's usually an easy one. We still should look at GCF, and we still should look at these more complicated trinomials. Okay, so this factoring, if I wanted to do this by factoring, I would look for that first case GCF, which this one does have. I can factor out, when you factor out a 3 of 39, you don't get 39, you get 13. But then that doesn't really factor as a difference of two squares, right? That's not, 13 is not a perfect square. So maybe we recognize this one is solvable by taking roots, right? And when I say taking roots, if we add 39 to both sides, we get 3x squared equals 39. And then I can take the square root of both sides and I get this answer. Or answers, I should say. I get two answers, plus or minus root 13. Okay, and that's it. Those are my two solutions. Now, you may have to sometimes write those as decimals. Sometimes the computer will ask you for that. So you'd have to use your calculator, plug that into your calculator. I didn't talk about calculators last time. You won't need a graphing calculator for this course, but they are helpful. But you definitely will need a scientific calculator. And even a basic calculator should do roots, and you could get a positive answer. You don't really write a plus there, whatever that is, and also a negative answer in decimals, whatever the square root of 13 is. It should be 3 point something. Okay, good. How about this one? Solve. All right, so if I wanted to solve this, I should recognize there's a common factor. So I'm going to try and factor it, and we'll get to those other two methods in a minute. So my step one of factoring was GCF. Can I factor out a common factor? I can. because they all have a y in it. Okay, now I got to try and factor that guy. I'm hoping that factors. All right, so good. So this would be, from my previous slide, case 4, ax squared plus bx plus c equals 0. My most difficult case of factoring. Some of you may be able just to do the trial and error method. 7y times y will give you 7y squared. And you can just kind of put the 5 here or here and a 1 here. There's not a lot of factors of 5, so that's good. But I want to show you the AC method, okay? So if you can figure it out without the AC method, that's fine. I fully support that. That's what I would try and do. But if not, we have a method called the AC method, where this is A, B, and C. So you multiply A by C. In this case, that's negative 35. And B is negative 34. So you need two numbers that when you add them together, they get to be the B term. And when you multiply those same two numbers, they give you the AC term. So multiply to get 35, you got not a lot of options. 7 times 5 and 35 times 1. It's going to have to be 35 times 1. And it's going to have to be the 35 negative. Okay? That's the only way to multiply to get negative 35, add to get negative 34. So that means the AC method, the whole point of it is just to really break up your trinomial 3 terms and make it 4 terms. So that is 7y squared, I don't change, minus 5, I don't change. We're still dealing with an equation. And I break up that negative 34y using those two numbers, negative 35y and positive 1y. Those are my y terms. These are my y terms, okay? So look, this is the same thing. Negative 34y is the same thing as negative 35y plus 1y. And then the next step is to do what's called factor by grouping. And I'm going to, I know this y out here might be confusing. You just ignore it. You already factored him out. He's just going to come along with each step. And I'm going to factor the common factor out of these two terms. That's going to be a 7y. And what does that leave you with out of just these two terms? Y minus 5. I'm going to factor the common factor out of these two terms. There isn't anything in common, but you can always factor out a 1. Always bring this sign with you. And if I factor a 1 out of y minus 5, I get y minus 5. Okay, so again, I'm showing you what I call the AC method on just this thing. Don't let this y confuse you. We factored him out, and now we're factoring quadratic trinomial, something that's squared. All right, and then finally, what I do is I factor out this y minus 5. I bring him out to the front. And what does that leave me with? It leaves me with the 7y plus 1. Okay, and now I can set each of these to 0, and I'm factoring to get 3 answers. Y equals 0, y minus 5 equals 0, and 7y plus 1 equals 0. Okay, so there's an answer. If I add 5 to both sides, I get my second answer. And for this one, I'll subtract 1. I get 7y equals negative 1. Divide by 7, and I get my third answer.